If A, -2, 1, B, A, 0, C, 4, B, and D, 1, 2, are the vertices of the parallelogram A, B, C, D, find the values of A and B. Hence, find the lengths of its sides. The first time you read this, you might think, okay, great, distance formula. You might sketch out a coordinate plane, plotting A at -2, 1, and D at 1, 2. But then we start to run into problems. B is located somewhere on the x-axis, and C is located somewhere along the line x equals 4. And while we could use the distance formula to find the distance from A to D, it would not help us find point B or C. We need a different strategy. In fact, what we need is a fifth point. First, we'll label our parallelogram A, B, C, D. Because we know that this is a parallelogram, the midpoint of line AC is also the midpoint of line BD. To find the midpoint of any line segment, we take the x-coordinates of the endpoints, add them together, and divide by 2, and then we take the y-coordinates of the endpoints, add them together, and divide by 2. We'll need the coordinates of each vertex. We know that the midpoint of AC equals the midpoint of BD. First, we'll set up two separate midpoint equations to find the midpoint of AC and the midpoint of BD. For the midpoint of AC, point A is our x1, y1, and point C is our x2, y2. x1 plus x2 equals -2 plus 4. y1 plus y2 equals 1 plus b. If we simplify this, -2 plus 4 equals 2, so we have 2 over 2, and 2 over 2 is 1 whole. The second point, the y-coordinate of the midpoint, cannot be simplified, so we leave it 1 plus b over 2. We'll follow the same process to find the midpoint of BD. Point B is our x1, y1, and point D is our x2, y2. That means x1 plus x2 equals a plus 1. y1 plus y2 equals 0 plus 2. To simplify here, the x-coordinate cannot be simplified. We leave it a plus 1 over 2, and the y-coordinate has a numerator that says 0 plus 2 equals 2, and the denominator is 2. We know that this fraction, 2 over 2, equals 1. The midpoint BD is found at the x-coordinate a plus 1 over 2 and the y-coordinate 1. But remember that these two midpoints are equal to each other. They are located at the same point. So we take these two coordinates and set them equal to each other. We have a coordinate pair xy being set equal to xy. And that means we'll need to take the two x coordinates and set them equal to each other, and then take the two y coordinates and set them equal to each other. 1 equals a plus 1 over 2, and with the y coordinates, 1 plus b over 2 equals 1. In this step, we'll finally be able to find the values of a and b. Looking at the x coordinates first, I want to get rid of that 2 in the denominator, so I'll multiply the right side by 2 over 1. If I multiply the right side by 2 over 1, then I need to multiply the left side by 2 over 1. 2 times 1 on the left equals 2. On the right, the 2's cancel out, and we're left with a plus 1. From there, I subtract 1 on both sides. 2 minus 1 is 1. On the right, the 1's cancel out, and we find that a equals 1. Because we know that a equals 1, we find out that our B coordinate is located at point 1, 0. Now for the Y coordinates, again, we need to get rid of the 2 in the denominator, so we multiply by 2 over 1 on the left side and the right side. On the left, the 2's cancel out. We're left with 1 plus B. On the right, we have 1 times 2 equals 2. From there, we subtract 1 to both sides of the equation, and we find that B equals 2 minus 1. B equals 1. Our second missing value is also 1, and that means that the vertex C is located at the coordinate 4, 1. If we wanted to find the midpoint, we would need to take the information we found for A and B and plug it back in. I know that B equals 1, 1 plus 1 equals 2, 2 over 2 equals 1. Our midpoint is located at 1, 1. Now that we've found the location of all 4 vertices, we can move on to finding the lengths of the sides. And to do that, we will need the distance formula. However, we will not need that coordinate plane. If we think about properties of parallelograms, we remember that opposite sides are equal in length. Side length AB is equal in length to DC, and side length AD is equal in length to BC. Because we know that side length AD is equal to side length BC, we only need to use the distance formula once for both of these sides. We'll find the distance from A to D and then apply that to BC. A can be our x1, y1, and D will be our x2, y2. That means we'll have 1 minus negative 2 squared plus 2 minus 0 squared. 1 minus negative 2 equals 3. We square that value. 2 minus 1 equals 1, and we square that value. 3 squared equals 9. 1 squared equals 1. And we find that the distance from A to D equals the square root of 10. And by that we know that the distance from B to C equals the square root of 10. We're almost finished, but we still have 2 remaining side lengths to measure. Side length AB is equal to side length DC. We'll find the length of AB and apply that to DC. Vertex A can be our x1, y1, and vertex B will be x2, y2. x2 minus x1, 1 minus negative 2 squared. y2 minus y1, 0 minus 1 squared. 1 minus negative 2 equals 3. Square that value. Plus 0 minus 1 squared, negative 1 squared. 3 squared equals 9. Plus 1, negative 1 squared equals 1. And the distance from A to B equals the square root of 10. What we've just found is that all 4 sides in this parallelogram measure the square root of 10. The solutions we were looking for, the values of A and B, both equal to 1. The lengths of its sides are all the square root of 10.